In the last video, we were looking at exponential functions that had the form y equals b to the x. There were a lot of things we could say about this function. We said, for example, that it passes through the point 0, 1, that its domain was all real numbers. Anything could go in for x, but even though anything can go in for x, only positive numbers come out for y. So we also sketched some graphs saying if b is bigger than 1, and that's more rounded, it grows very quickly if b is between 0 and 1. I guess I need to add my stipulations there. B has to be a positive number that's not 1. And so if b was bigger than 1, then we had growth, and if it was between 0 and 1, we had decay. And we agreed that both of these shapes individually passed the horizontal line test, so there was an inverse that existed for that function. We set up the situation where we would go to find that inverse by changing x's to y's and y's to x's. And then we said we need to solve this for y. And that's where we got hung up. That's where we stopped. We said there's not an algebraic method that we can use. I can't multiply or divide both sides by something. I can't add or subtract or do any kind of roots or radicals there or raise to a different power to get that y down on the ground. And just because algebraically I can't do this doesn't mean that the function doesn't exist, because I know a lot about this function. I know this inverse goes through the point 1, 0. I know its domain is positive numbers and that its range is all reals. Okay, I could even sketch a graph reflecting this across the line y equals x, or that one, to get a general shape for that graph. Okay, but again, algebraically I get hung up. So what we're going to talk about today is this new family of functions that says if x equals b to the y, okay, that is true if and only if log base b of x equals y. Okay, we're going to talk about logarithm functions, and our logarithm functions are functions that are inverses to our exponentials. Now remember that an if and only if statement is one that can be read in either direction, meaning if I start with the stuff on the left, I could write it in terms of the right side, or if I started with a statement on the right side, I could go back and write it in exponential form. Okay, exponential form is using exponents. Logarithmic form is where I write it using logs. So maybe I'm going to say 3 squared equals 9. Okay, so I have my b to the y, and my x, I just switched the sides the way I wrote the equation. If I want to write that in logarithmic form, understand the base. This base b is the same as the base of my logarithm. Okay, it's a subscript. It's supposed to be a little bit lower. I kind of missed there, but it's supposed to be a little bit lower than the word log. Okay. My x is the stuff across the equal sign right here. Goes inside, so that would be my 9. Okay. And I'm saying b, so I'm writing b, but that's my 3. And then the exponent is this piece across on the other side. If I have the statement 3 squared equals 9, in logarithmic form I would write log base 3 of 9 equals 2. If I have the statement 5 to the 1/2 power equals square root of 5. Okay, we read this guy in a circle. The base on the ground b to the y power across the equal sign equals the stuff inside, which is x. Okay, 5 is the base of the exponential part of the equation over here. The exponent, the 1/2, goes across the equal sign. and the square root of 5 goes inside. 5 to the 1/2 equals square root of 5 in logarithmic form. It says log base 5 of square root of 5 equals 1/2. Maybe I have 2 to the negative 4 power equals 1 over 16, or 7 squared equals 49. Go ahead and pause the video here in just a minute, write them in their logarithmic forms, and then turn it back on to see if you're right. The base up here is 2, so that's our subscript. The exponent of negative 4 goes across the equal sign, and the stuff inside is our 1/16. Here the base is 7, the exponent is 2, and the stuff inside is my 49. 7 squared equals 49. So let's do some going in the other direction. If I have log base 3 of 1/9 equals negative 2. Now going backwards, I know the base of my logarithm is the base of my exponential. I know across the equal sign, that's my exponent, equals the stuff inside. If you're practicing with these going back and forth, the statement we have here on the left side, the exponential statement, should always be a true statement. 7 squared equals 49 is true. 2 to the negative 4 equals 1 over 16, true statement. Okay, so make sure that these are right, and that way if you flip-flopped something and have it in the wrong place, when you go back and look at it, you say, well, that's not right. How do I need to fix it? So, take log base 2 of 8 equals 3 and put it back in exponential form. Log base 5 of 1 over 125 equals negative 3. That's a negative sign. So pause the video, put them back into exponential form, turn it back on to see if you're right. Log base 2 of 8 equals 3. 2 is the base. Across the road, 3 is the exponent. 2 cubed equals the stuff inside, which is 8. Down here, 5 to the negative 3 power equals 1 over 125. In the next video, we're going to practice of these 3 pieces here. We're going to give you 2 of them and leave out the third, and you should be able to set it up and find that missing piece. So next video, we'll practice some of that.